The tilted distribution pole, as I saw observed this tilted distribution pole in my locality. What might be the mechanical danger chain? The stage 1, immediate mechanical shift. Uneven tension in the conductors. As the poles are tilted, so the uneven tension in the conductor are going to create. What might be the cause? Tilted pole changes the pull direction, and hence what is the effect which we are seeing? One side tightens and the other side sags. What is the formula which we are going to see? The force component due to tilt. T horizontal is equals to T into sine theta, where T is the conductor tension S and which has the value about 1200 Newton. We'll see that how this 1200 Newton came. Theta is equals to tilt angle is equals to 15 degree. So TH, that is the horizontal tension, is equals to 1200 into sine 15 degree, which is approximately equals to 311 Newton. This extra 311 Newton of sideways pull adds to base and the next pole. Thus, it needs to fix very immediately. So let's calculate, as I said earlier, that the conductor tension, how the value 1200 Newton came. We are going to use the standard sag tension formula, assuming parabolic catenary approximation. Thus, the formula is T is equals to WL square by 8S, where T is the tension in Newton, W is the conductor weight per unit length, that is Newton per meter, L is equals to span length, that is in meter, S is equals to sag, which is also in meter. Let's now use the realistic distribution line values. Conductor type, we are going to take ACSR. Weight W is equals to 11.8 Newton per meter. Span L is equals to 40 meter. Sag S is equals to 2.0 meter. Thus, using the same formula as we just discussed. So this tension is approximately equals to 1180 or 1200 Newton, which is the value we previously used. The second one, that is an uneven sag in the conductor. What is the cause? One side has more tension and the other side is less. What is the effect of these? Clearance from ground reduces, and which may lead to electrocution of wire risk. Actually, the capacitive charge in case of the distribution line is very less, and hence the electrocution of wire risk increases. What is the formula for finding the sag? Let's see. S is equals to omega L square by 8T. Omega is equals to weight, or W you can say, is equals to 12 Newton per meter. L is equals to span, which we are taking about 40 meter. Span is the distance in between the two poles. Normal tension is equals to T is equals to 1200 Newton, as we just used before. S normal is equals to 12 into 1600 by 8 into 1200 is equals to 19200 by 9600 is equals to 2.0 meter. If tension reduces to 1000 Newton, which is because of the tilted side, so S tilted, that is a sag, tilted sag is equals to 12 into 1600 by 8 into 1000 is equals to 19200 by 8000 is equals to 2.4 meter. This 40 centimeter extra sag may break the clearance limits, and the norm is 5.5 meter. So it also needs to fix very immediately. The second stage, that is a structural and hardware stress. Pole-based bending moment increases. What is the cause of this? Lateral force acts due to the tilt. As the pole is tilt, so there is a lateral force acting on it. What is the effect of that? Foundation cracks or pole breaks. The foundation of the pole is going to break. And how we are going to find that? Is there any formula? Yes, there is formula. M is equals to F into H, where F is the horizontal force is equals to 311 Newton from above, as we discussed. H is equals to the conductor height from the base is equals to 8 meter, which we are taking. M is